Well, welcome back to our podcast today, our last little series on implementing research-based design in educational games as serious educational games for avatars and open world. So let's just talk a little bit about how we start to build a deeper game experience, one with some life to it. One of the things that you might want to do in the beginning of a course as you move into is the idea of building an avatar table. So what an avatar table means is that students would choose a different character when they started the game. For example, in Professor Debfell's work at Ryerson, there's characters that people could choose, and groups could actually choose a character to represent. So this is a typical avatar effect. What you'll see in the way video games work is that there's generally an ability each avatar has. So for example, the lockpicker has something called a battle cry, which can destroy an enemy, and then you have the Shadow Master, which gives a stealth. And then you can choose an enemy minion and steal its death rattle effect. There's all these different things which are unique to games. In our very early iterations in Healer's Quest, the work we did at Ryerson back in early 2002 and 2004, we had different avatars that were simple. So you could enter a game of medical simulation as an alchemist, for example, and a seer. And the alchemist could give medications, but the seer could do radiological investigations. So the idea of producing an avatar table, a role for your student to play, and we're doing some of this work. We're just starting to do some work with a colleague of ours that we hope to interview in October, and this is Dr. Amanda Wintink here at the Guelph Humber School of Psychology. She's a psychology professor, and we're building out game systems that recognize different professions. So when someone graduates with a psychology degree, they may go on to become a psychologist per se and see patients or whatever, or they may be a scientist that studies psychology, or they might work in the area of journalism using psychology as a jumping off. So the idea is that you could develop your character in different careers, and you might have different kinds of characters that you want to generate in a game. There's nothing saying that you can't be 3 or 4 avatars in a game. So you could develop a part of you that's learning to be a scientist. You could also develop a part of you that's trying to become a clinical psychologist in this game, and they would have different learning goals associated with it. So avatar tables are generally, again, a description of the different roles that a person could play in a game, and then what they want to do with that role has to do with the game design that follows. So what we'll often do is you would create a life path. Now in this case we talk about a life path for an illness. So in any kind of simulation that you give your learners to do, you would have to have them think about what happens next in course of what's called a life path. So let's just talk about a life path here and how you build it. You might take a student over a 10-minute period and set some probabilities by using a dice roll to look at the life path of depression. So in depression would normally get worse and worse over time, but if you over a 10-minute period are able to identify medications that you may want to suggest, then you would learn about those medications over a 10-minute period, and then you would try to apply those to the case and the life path of the illness that you're trying to treat. So again, you could use a dice roll as you roll the dice. This could give you different probabilities for success of your medication. So we talk about the idea that we want to create cases, we want to create untalks and create probabilities. So we unlock more difficult cases by doing the early one with our avatar. Then we can use dice rolls to create probabilities, and then we can work into it. And this is called open world training using smart decision trees. Now, this really has to do with this idea of creating a patient biography, for example. And patient biographies aren't necessarily all about humans. This is the work by Norman Cousins that talks about a biography of an illness. But you could talk about the biography of anything. It could be the biography of building a new business or the biography of building a new house. There's a biography that is a life path, a series of things that are going to happen to that virtual object in that virtual game environment that you're going to work with over time. And so what we generally do, for example, is we create a year, a week, a month, or a year in the life of that. So, and this would be the untreated. That is one where we haven't really made an intervention. So let's look at day 1 of a construction project as your case. So again, the case study is built to give you a progression of how that virtual object, like the house, might evolve over time. So I know this is a lot of new language to take in, a little overwhelming, but let's just break it down. Let's look at what happens of the days in a construction project. So day one, you would have that the teams met at the job site and began to do the footings and start to work on the foundations. Now we can put in a life path for that house. On day two, you get a very heavy rain and the whole work site is turned to mud, and you're not sure about which things that you can continue to work on when you have very, very inclement conditions. Or let's add some snow and ice in an ice storm and talk about how you're going to strategize, still getting the house built to deadline, even though your workers are now in the middle of an ice storm where everything's freezing up on them. You start to see what we do? Now, day three of the project, we could have things go very, very well, and the footings and the foundations start to move in. Day four, there could be a delay of work materials. So now you found out that it's going to take you another 3 weeks to get the marble that you need for the countertops, and it's going to take you some time to get the flooring. So you have to prioritize getting the flooring so you can put it in, but you'll wait on the countertops, which means you have to go back to the client and say, you know what, we can't get your house done in time because it's going to be another 3-week wait because we have a short supply of marble coming from Italy to do your countertops. On day 5, it could go well, but we might find a problem in the electrical panel, and we could have some difficulty with the electricians. Perhaps this is a renovation, and they've discovered that the old wiring has to be replaced. Do you see what we're getting at? So when you build a simulation for an open world game, think of this idea of a life path. In this case, it could be for the house, it could be for a patient, it could be for the production of an automobile. What happens in each day or month or year of that project, which then allows the student to have to adapt to changing conditions, and it becomes a more realistic simulation. You're not just building a house, you're dealing with all of these things which might be introduced week after week on a learning management system, or maybe through introducing cards or having the instructors simply stand at the beginning of the class each week and say, welcome to day 2 of your construction project. Here's what's gone wrong today. What are you going to do about it to make it successful? So if we do it in terms of medical things, each day we would roll a dice to see how the patient does, and we could have students formulate interventions. So the idea here is that you could actually use a die roll to say is your house going to work or not. You could use a die roll and set the die roll probabilities so that various things happen. So you don't have a static case development and life path for the virtual object. The virtual object can be affected by die rolls. We rather want to talk about another little element in our last of our series here on how to integrate introduction of case studies. We don't have to do it in paper and pencil or PDFs. Using a 360 camera is an extremely powerful way of producing an impactful presentation. So a 360 camera looks something like this. We've got Ricoh here we use at Humber, but you can use LG, you can use other brands, and they're not that expensive. They're under $500 for a 4K HD camera. And what you can actually do is allow control of the video by the student. So you'll see in a 360 camera that people can put on some VR goggles from a YouTube site, or they can just use a cursor and kind of scroll around the screen. And this gives them control of the video. So you could take them to a job site and use a 360 view of the inside of the house that you're working on as you're building it, and then present the problem in text along with it, or have someone speak on the 360 view. It's so much more compelling for the student to enter the game world and to get an idea of what they're doing in reality. So we use the 360 video to actually present the concept. And we can actually also use it in medical training and treatment. There are all kinds of 360 videos that are used to look at surgeries and operations, etc. And you could be interviewing people that have drug addiction in 360, or looking at someone that's applying for a job using 360 video. So this is a very powerful, compelling way to actually provide the case information for the open world game event using compelling. We can also use what are called triple jump evaluations, and these are kind of interesting. In a triple jump, there's 3 different stages. You've got a hop, step, and jump. So what you actually do in triple jump game design is that you have the student take the first part of a case, and then if they do well on it, then you give them the next part of the case, then you give them the third part. So each case could be sequenced in each part. So what we showed you earlier was a game world where you plan out the progression of what's going to happen with your virtual object. Here you can actually set it into 3 stages. So day 1, you arrive at the job site. What are the different team members that need to be on the job site to get the foundations in and to get the build going? So once they've filled out maybe a page, something on that explains how they're going to do that, then they would release, okay, this is the second second part of your project. The house is now built. You've got the foundations in, and you're getting framing going. What kind of things do you have to do when you're doing the framing stage? What kinds of professionals? Do you want the drywall folks to come in? Do you want the electricians to come in, the plumbers to come in, etc.? Once they sign off on that and they say, that's what I want to do, here's the third stage of the problem. Now the house is almost ready. What kind of team are you going to need to do the finishing? This is where you do the painting and the appliances, etc. So this is called a triple jump. It's where there's 3 stages of a case rather than this kind of idea of an evolving timeline, and at each stage they have to make decisions. And the idea of triple jump evaluations is a product from McMaster University Medical School, where they wanted to find ways to test medical students which didn't use exams. They wanted to look at how they solve problems and look at their problem-solving attributes and to do these kinds of measurements. So again, this idea that you would provide a case, students provide an action plan, provide the next stage of the case, provide a second action plan, etc. This is what's called a triple jump learning. And this can resemble the point of what we call objective structured clinical examination, OSCE format. That is that they can go from each room to room, or different parts of a classroom, or different parts of an LMS, different discussion groups within an online learning module, and each one of these they could have various things they have to do, and you can actually measure the student performance by looking at how they answer multiple choice exams, or observing them, having them submit material if it's a physical thing like massage, or something like making drinks, or making a cake. You can have them observe that process. So you can set up these simulations as challenges that can be observed, so you get feedback on the instructor at how people are doing, and then you can do just-in-time transformations to provide new content to make up for any kinds of problems. And our last little talk is to think about how, a little part of the talk is to talk about behavioral neuroscience design, and that is how that we set up these games. And you got to remember, this is Richard Bartle's idea of different player types, of socializers, killers, explorers, and achievers. So think about the educational game you're building as appealing, having elements that appeal to socializers and competitors, explorers, etc. So the game isn't good for just one type of person. Now, what was very interesting is that we've discovered that as people enter your educational serious games, they're going to have different player types and flows. And this is the work of Gabriel Barada and their team from Portugal. And this is the best study on the long-term use of gamification. They looked at game learning over 3 years in a course. And they discovered that there were many different player types that emerged. So some people loved the game and stayed with it all the time and did everything you asked. Other people didn't really like the game. They did what they had to because it was the course, but they did as little as possible. Other people liked the game initially, but after the first year were kind of bored with the idea, so they didn't put as much work into the game in the second year. It's a very good paper worth reading, studying student differentiation and gamified education. And it'll probably give you a pretty good look at how students are likely to respond to fully gamified course offerings over time. And they did a lot of data collection in preparing this paper. They looked at all these different elements and tried to make some measures, and they were able to, by an analysis, cluster people into different groups. And there was about 6 or 7 different types of games, different than Bartle's idea of 4. There was different people with respect to the motivation that they had and the amount of investment they put into the game. It's important to develop ways of tracking progress in any form of serious educational game, especially these which involve open world design. So you want to have some kind of progress bars. We know in Blackboard Learn there are progress bars that you can use to work your way through materials. And you may provide informal ones or written progress bars. But to remember that the learner in an open world game needs to know how they're doing and how they're advancing in each of their level of skills. They don't want to just float around in the game, never without any feedback and without any idea of the progress that they're making. We need to build these elements into the game. We can do this a lot using adaptive release, using a learning management system, and we've done quite a bit of work here at Humber on building out games that use adaptive release. So essentially what adaptive release means is that they can't see one module, they're a rule, until they've done one. So you can do this in a relatively conventional way, in which you have a lecture, and then you have to write an exam quiz, and once you've written the quiz, it gives you lecture 2, etc. But you can set adaptive release that these are different parts of a case that are revealed. So initially, the first part of the case could be a 21-year-old person comes in, and they're looking to try to find a career, a path for themselves. They're not sure. You're working as a guidance counselor, so then there would be some multiple choice questions you might have to answer about what kind of resources should you provide for that young person looking for a career. And if you get that answer right, then it reveals the second part of the case. The second part of the case is now the person is beginning to explore job options in a career that you've recommended. What kind of resources can you provide? So you can even provide HR training, and we're doing some work with HR here at Humber in ways of using gamification to look at how people will deal with real-world case. So this all uses this element of adaptive release in a learning management system. Almost every learning management system has an adaptive release feature. So remember, you can proceed through the game based on the merits of the work you did prior. And this has to do is of the behavioral neuroscience of dopamine that underlies this. And this means as you're starting to think about having a coffee, your dopamine concentrations start to go up. So as you're getting ready for the coffee, it's going to peak up, but as you drink your coffee, the dopamine's going to drop. So what we know is from the moment you begin to smell the coffee and get the milk and the sugar and get yourself ready to drink, your dopamine concentrations are increasing over time. So this is what's going on in your game design. We're trying to build these elements in a game that are going to increase dopamine, which is the desire to do something and to get rewarded. But we know as soon as they have the goal, that's going to drop, and we're going to need a second reward. And so this is the nature of dopamine, the nature of keeping someone in a game, of always wanting more and more. Look at how gambling works in casinos. People just want the next loop. So these are called multiple compulsion loops. We've spoken them in other podcasts. And this is the idea that you want many things to do in the game that are going to trigger dopamine release in the brain and produce these compulsion activities. Ultimately, we want dopamine, norepinephrine, and serotonin levels. We're kind of playing with all of these. So we're trying to bring some of these neuroscientific principles into action. We're not going to break this down in too much detail. I think you also already get the idea about dopamine and some of these neurotransmitters such as serotonin and the part they play. What's interesting and what we would conclude with is the work on 5-HTA receptors, especially the type 2 receptors, that seem to be related to broad behavioral change. So it appears if we stimulate serotonergic receptors the right way, by giving entirely new ways of looking at the world, ways of reconceiving problems, reframing, reconceptualizing, we're engaging these 5-HTA receptors in the cortex. And it appears that we have this ability to look at the world in dramatically new ways. And so this is one of the higher level goals that you would have in producing a learning game design, to really get the person to see the world through the standpoint of being a psychologist or being a master planner and contractor, to really kind of reshape how people organize information in a fundamental way. And these are the kind of things you can do by being in a game world where you apply these rules to reality, and reality reflects the changes the player has made. Serotonin, similarly, is a self-soothing chemical. So in game design, we want to provide a lot of elements of serotonin release. So this has to do with activities that make the person feel good. And feeling good is solving a difficult problem, and when you solve it, you feel great. So dopamine is these kind of things which make you want more and more reward, but we want there to be some kind of acknowledgement. And the way we can increase these serotonin levels often has a lot to do with how much of a reward we actually build into the game. So leading up to the reward, we have dopamine release, but after rewarded, serotonin release increases. And serotonin is about feeling good, a feeling of accomplishment. So you want there to be these waypoints of accomplishment. You don't want the game to just provide constant challenges, but no real feeling of satisfaction that's built into the game system. We also want to build oxytocin into games, which regulates social circuitry, and we know that we want people to be really, really excited about working with other people, and we want to feel this sense of connectedness with other people, and that this is going to enhance learning. There's a lot of neuroendocrine inputs as oxytocin release occurs, so emotional and social regulation is going to occur, but this is why we often have people work in groups, so that there is this sense of community building and also enjoying rewards together as a group. And we know from the work of oxytocin in digital media that we have oxytocin nasal sprays called instant trust. And this is the whole idea that we relate to computers very much like we relate to people. So if someone slaps us around in the computer with a bad website, or we read Facebook posts that are very disturbing, we relate to it like we relate to a real person. We might get angry with the poster, we might get angry with Facebook, we might get angry with the website. So remember that in the digital medium, we can influence feelings of connectedness by building the web experience, using the user experience for the game be one which is inviting. Because as the person plays the game is almost going to be like a human being, and we have to be sort of aware of this. The other thing we'd have last, and to conclude on, to be aware of, is the role of cortisol in games, and that if we have cortisol release that's constant, where we're under stress in a game, then we can't learn effectively. But if cortisol releases occurs in short bursts, we can actually see heightened arousal, and we can see people really develop well in the game, using stress mechanics like timers and setting time limits on things to make people kind of engaged. The last neurotransmitter that we consider, and there's not much literature on it, learning, but we know it's a major learning neuromodulator here. This is misspelled in this slide, neurotransmitter. But essentially neurotensin has a lot to do with learning, and it seems to be key involved in mentalizing. And that is the ability to actually see what another person's doing and understand their point of view, what we might call empathizing. So can you build some neurotensin-based activities into your game? Do you have ways for people to try to get behind the cockpit of another person? Maybe you're learning to be a pilot. Can you get behind the brain of what it's like to be a pilot who's working a very difficult kind of route and encountering inclement weather, etc.? How can you actually do it? So can we build these in? And usually we do that with things like VR and role-playing within the game, which comes back to our original statement about avatar development. Can we actually have people take on the point of view of an experienced professional and try to see the world through their eyes through some of these changes? I hope today has been very interesting in wrapping up our little series of presentations on how to use the literature-informed game design to move people in higher education to more refined and more effective, authentic alignment in outcomes in education. David Chandross for the Center for Teaching and Learning here at Humber College. We'll see you next week. We read the journal so you don't have to, and we've maybe given you a little bit of a background to get you excited about building your first open world and deeper game designs. Thank you.